This conference will now be recorded.
Okay, I think everybody is see the Excel sheet here. So it is span quiz 2, question number 1. Is power lines contact with the object created problems? Yes. Its answer is yes. Each power lines contact situation poses different problems due to the power
Uh,
lines capacity.
Someone mic is switched, not muted. It's
Okay.
their problem.
Okay.
I think Mr. Abdul Ghaffar is not listening to us. Maybe he left. His mic is still not muted.
Yes, the option is muted here. See his
Now I
option.
No,
Abdul
no.
Ghaffar.
I am here in the session. I am listening.
Okay, okay, okay. So we are discussing about, is power lines contact with the object create problems? Yes, obviously when there is a power lines contact with any object, it creates problem. And due to the capacity of the power line, any fault in it, or the environmental situation like raining and other wet condition and other conditions may be pertain. So the answer is each power lines contact situation poses different problems. The second one is what action to do by a crane operator if the crane rubber tires has stuck up power lines. Answer is that generally accepted guidance is for the crane operator to stay in the cab until the emergency crew arrives, because he is in danger, and his crane is stuck in a power line which is energized, or maybe it is not energized, but he is in danger. He should have wait for the emergency crew arrive. Third one is
can I
what
just
are,
give my input to this question?
yes, sorry,
Can I give some input to this question? Maybe it will be
yes,
just
yes, yes,
more
yes, yes,
information. Once
yes, yes,
there is contact between the crane and the power line, so now this crane operator should stay inside the crane because the crane and the power line now in the same potential. But let's suppose if he want to jump from the crane, at that time it's possible that once he touch the ground, so there is a different type of potential because the ground is at zero potential and he is in high potential, so all the current will flow from him and he will get die at the spot. I think there is some distance around the crane. I forgot now that what is the radius, but I think it's 5 meter or 4 meter. That ground is energized. When he's stepping from one step to another step, so from one step to another step, there is a potential difference because there is a distance. So that time he can got electrocution. So he should stay inside the crane. He should never exit from the crane.
okay,
Okay.
thank you, bro.
Thank you, bro. I will add a few more things in this. Like whenever a person jumps, as Mr. Ashfaq has said very correctly. So when he walks, because there is a whirlpool of current, like in circles, in concentric circles, all the current will be flowing. So whenever he makes his, moves his step. So one step and the other step, there will be a difference in potential where that person will get affected by an electrical shock. So usually they say that whenever you are jumping, we need to jump in that circles. But we don't know that the exact jump which we are making in that circles is correct. If that there is again a difference, then you can burn yourself. So it's better you stay inside the vehicle.
Okay, that's nice input. Okay. Okay, then we will move to the next. What are the reclosure which equipped in the power lines? As you know that in our household appliances, household circuit breaker, we have household circuit breakers that remains shut off until it's manually reset, or if a problem occur or any electric short circuiting occur, the power is break, and these circuit breakers remain shut off until it is manually reset. So in the same concept, in the power lines there are reclosure installed. You can see the picture of the reclosure. Here is the reclosure picture. The first one is for the single phase, and the second picture is was the third phase reclosures. The function of the reclosure is an automatic high voltage electrical switch just like a automatic high voltage electric switch, and like a circuit breaker. And these reclosures are test the electric lines to determine whether the trouble has been removed or not. And these reclosure test their self for 3 or 4 repeated cycles, whether the line is disconnected or whether the fault is removed. These reclosure test themselves. So yeah, these are the automatically reset. So the in a power line, the main function of these reclosure is that which I already explained. So anybody have some input on this point? Okay. Next, we will move to the next question. When crane operator departs the cab of crane, and how he departs, as Mr. Mushtaq already explained well. In case of fire, if there is a fire in a cabin, then the crane operator who is waiting for a emergency crew or for help, he is now jumped from the cabin with the feet together, is only the safe depart method. You know that the sack race step kept minimum, and jump minimum jump and cross the circle of that uh, electrical circle. So I think it is 5 meter, which Mushtaq Sheikh already told you about that. The exact we will see the exact uh, where the circle is located. I think it's depend upon the power line capacity. If there is a low voltage, low line voltage, I think the circle is small. And if there is a high power line voltage, then the circle is big. I think this is the logic. So anybody has some input in it? Okay. Now we move to the span quiz 2, question number 19. What are the categories of explosion? As NFPA, there are two general categories of explosion: physical and chemical. Physical or chemical. In physical explosion, the high pressure gas release is produced by a mechanical means, and even if chemicals are present in the container, they are not affected by chemically by the explosion. Basically, the criteria in physical explosion is the gas is produced by the mechanical means. But in a chemical explosion, a high pressure gas is generated by chemical reaction that takes place within the fuel or explosive material. So the two categories, there are as per the NFPA, there are two categories. Now the next one is, what is the oxidizing agent? You know all that the oxidizing agent, known as oxidant, yeah, or oxidizer, is a substance that has the ability to oxidize other substances. In other words, to accept their electrons. What are the oxidants? Ammonium perchlorate, hydrogen peroxides, perchloric acid, sodium perchlorate, bromine, chromic acid, and benzoyl peroxide. These are the strong oxidizers and are capable of forming explosive mixtures when mixed with combustible, organic, or easily oxidized material. So move to the next one. What is result of decomposition of explosive material? You know that the decomposition started when the chemical oxidizer that must be present in explosive material allow for a rapid acceleration of combustion required for the explosive decomposition is to occur. This is sometimes referred to as violent release gas. The next question is that what is the requirement of chemical explosion to occur? You know that the in a fire tetrahedron there are four items are required: oxygen, or ignition, source of ignition, heat, and other is the chemical reaction. So for a chemical explosion to occur, there must be oxygen present in the compound. In this case, chemical oxidizer, because atmospheric oxygen will not provide enough oxygen, fuel for combustible filler, an ignition source, and most importantly, confinement of the oxidizer and fuel. Without confinement, the material will not explode. They will burn with the great intensity. Only they will burn with the great intensity if the if the confinement is not present. So you know that in the latest bomb blast in Beirut, Lebanon, the oxidized material is confinement in a containers, and there was ignition sources, and there was already fuel is present there. So a big massive pounds of explosion was done. And you already know that for a bomb making, the strong oxidizers, ammonium nitrate and a urea nitrate is used. And in Yokohama incident,
Careful about this topic, Mr. Imran Aslam.
yes, sorry.
You should be careful about talking about the bombs, etc., etc., because we are here in Saudi and all the things are recording. You can give another example.
Okay.
On a
No
lighter
problem.
note, okay?
Basically, I read the book of reference which the span is referred. So I am giving the example from that.
Okay, continue. Sorry.
Okay, yes, you are right. Chemical explosion to occur. So without confinement, or confinement is a state of existing of our oxidizers itself. So without confinement, explosion will not occur. So that's end of my question, assigned questions. So if there is anything or any input, you can share with the participants.
Yeah, like in the cranes, usually we say that a crane should be 20 feet away from the power lines when we are working, like power lines like 350 kilowatts. If it is more than 350 kilowatts, then it should be 50 feet away. This is as per OSHA 29 CFR 1926 1400. Okay, this is saying that we call this approach as encroachment prevention measure.
There is, Mr. Mushtaq, maybe I read wrong, but the minimum distance we should keep for any power line for a maximum 50 kVA. This is 10 feet. And about that, there is one formula. I will just check it tomorrow and I will share in the group. There is one formula by which we will calculate the distance. Now I forgot that formula, but I think this is 10 feet.
The 10 feet is for lower voltage, right? This is I'm talking about 350 kV and above.
I'm just talking about the 50 kVA. Above the 50 kVA, we need to use one formula.
Yes.
Yeah.
Okay.
Yeah. Both are correct. But there is voltage difference. Both formulas are correct. Both guidelines are correct.
Okay, thank you.
Okay, thank you.
So I will share that formula tomorrow because this is very important. Sometimes this question is coming in the exam. They will just give you the power line and what should be the distance. So we need to remember that formula.
Yeah.
Okay,
That's
Mushtaq, the formula or the KV's difference is from the top of the crane or from a surface of the ground of the crane?
No, from the
Power
top of the crane to the cable lines and power lines I'm talking about.
Okay,
So
okay.
usually we take like 10 feet distance. This is what we follow in our construction areas. But as per the standard, like OSHA 1400, 1926 1400, what it is saying is 20 feet. Because I remember because here one more word is coming, like we call it as encroachment prevention measure. This is called as mandatory. Like whenever there is a keeping away the crane.
Okay.
Like 20 feet off the power lines when we are working with operating voltage of more than 350 kilowatts, and 50 feet of away if it is more than 350 kV. This is what I remember. That's what I thought to share, because usually I think this type of questions has been twisted and been asking in the examination, So we need to know how, because sometimes 11 kV it asks, 33 kV it asks. We don't know what type of question he will be asking.
Okay. That's nice. So now the next term is Mushtaq Sheikh. Are you presenting something, or Mr. Mushtaq, are you presenting something?
Sorry, I switched off the mic. Actually, I sent my Excel file to you. You need to open that so that I can explain, because I'm always doing with my mobile.
Okay.
And everybody.
Okay, the screen is okay. Sorry. Okay, now it is clear.
Yeah, one second. Let me open.
Okay.
Yeah. For your information, there is one of my friend here, Mr. Ibrahim. I want to just introduce him. He's working in Aramco as a HSE manager, and he's my friend, and he also want to prepare himself for the CSP and ASP. I think he's regularly attending the class since last 2 days.
Okay. Welcome, Mr. Ibrahim. Welcome.
Welcome, Ibrahim, on board.
Thank you, sir. Right now, I'm working in upkeep plant as HC manager with Nisma Tata. So, how are you, sir? Hello, guys. Everyone is fine?
Yes, yeah, we are all fine, and we welcome you. And we expected that you are regularly attended these sessions and increase your knowledge, and we will also learn from you.
Yeah, sure. So actually these days I'm not that much free, but I just want to listen you people. So actually I'm also preparing for another exam. So this why I'm not input this much. So
Okay.
yeah.
Okay. Thank you.
Thank you.
So go ahead, Mushtaq sir. Go ahead.
The first question is related to the firefighting systems, which is having a quick reaction time. It is basically about the reaction system. In this, we have a wet pipe system, dry pipe, deluge, and all reaction time. Yes. So in this, we are asking which firefighting system has a quick reaction time. So we call it as a wet pipe system. So what happens in wet pipe system is the pipe remains filled with water. So once the heat sensitive sprinklers heads are triggered, then water flows through the activated sprinkler to the direct source of the fire. So this system has quick reaction time, but run the risk of freezing in a cold environment. So somebody is working in a cold freezer room. So where we put this system, then it will not work. but wet pipe system is has a very quick response time when a fire take place. Coming to the second question, is this okay? First question.
Yes, going good. Thank you.
Yes,
Going
okay.
good.
Yeah. The second one is the response time is slower in which type of firefighting systems we are talking about. Okay, so we have a different type of firefighting systems as we talk, like a pre-action. So pre-action we have three types. Again, we can say that a single interlock, double interlock, and there is no interlock system also, where there is a air is there, and when the air releases, and then the fire will the sprinkler will start, the water will flow into that pipeline. So in double interlock system, response time is slower than that of a single interlock pre-action system. Or we can say there is one more system, as the first question says, wet pipe system. And the third one is like in the museums or art, where in the museums we have an artisans are present in a museum. So what type of systems are best suited for such conditions? So we usually say that a double interlock systems are useful for the protection of extra water sensitive items that cannot afford to be lost, such as museum artisans. So I will be giving a little bit more deeper input regarding this double interlock system and the single interlock system. So these are usually deluge systems. So in the deluge systems, what happens is, you know that wherever there is a sensitive area, so like the cold store or the freezing chances are there. There what we usually do is the pipe is filled with air. So in single interlocker, the what we say, the detection system gets activated. So when the detection system gets activated, so the air is released immediately from the pipeline, where the pipeline the pipeline is going. So when the air is released, the water reaches up to the sprinkler head. So we have a fuse bulb over there. So whenever the temperature temperature is reached, what happens is this gets melted away, and the water sprays in the particular area. But whereas in the double interlock system, we have two things available, like the we can say like the detection device is available, and the automatic sprinkler which is also available. In this we call this is actually controlled by a control panel, it is having circuits configured with what we say as a cross zoned operations. So like one circuit is connected to electrical detection system, and the second is to low air supervisory switch, we call it as. So whenever in this double interlock system, what happens is, when this the supervisory switch is activated, then the air will be released. Okay, then this there is an electrical detection system is available, so that also need to be detected. So both the systems should work. If only the detector is activated, then we receive an alarm, but water will not be sprayed on the fire. But at the same time, the second one is the second what we call as a cross zoned operation. The second one also should work, that is the supervisory switch also should work. So once it is working, that the bulb will fuse, then only the water will be released from the deluge wall. There is a deluge wall, so always the water will be up to the mark of the deluge valve. So once we open only this gets opened when both the systems, the electrical detection system and the supervisor switch, both of them gets activated, then the water comes into the flow. So that is how this is related to the first second question also, like why the response time is slower. Understood this one, or you need more explanation regarding this?
Yes, understood.
Yeah, this is as per NFPA 13. Whatever these details are there, these details are as per NFPA 13, which talks about the sprinkler systems.
What about the pre-action system? Can you explain?
Sorry?
Pre-action system, pre-action.
These two, in pre-action system, we have a double interlock, single interlock, and the non-interlock systems are there. I'm talking about this one only.
So what is the main principle of the reaction system? Working principle.
Working principle in sense, I'm not
No,
sure
I just
about it.
read something. Maybe I'm just wrong. In the pipes, they already fill the air with some, measure pressure. And,
Yeah.
there is one sensor which read that pressure. And
No,
let's suppose
actually,
if there's
actually, what happens is water will be there up to the deluge valve up to that. So rest of the pipe will be filled
this is
with
not.
air. That air
I'm
will
not
be
talking about the deluge system. Only a
yeah.
reaction system.
I'm
Simple
talking about
reaction.
pre-action only. We call it as a deluge valve. So up to that valve, water is there. The rest of that pipe is filled with water. We call it as a dry pipe system. In this, we have this interlock system which is available, which comes under what is pre-action systems like.
So you are saying that deluge system and reaction system are same?
No, it's not same.
Yes. So what about the reaction system? Omit the deluge valve from there.
No, it's a technically a little bit differences there, but it comes under that one only. What we call fire suppression systems. Under fire suppression system, all these four sets come together.
Yeah, but what I just read that there is some, in reaction system, the pressure inside the pipes, let's suppose they are fill this with some measure pressure, set pressure, and there's one sensor which detecting that pressure. Let's suppose if there is any fire, there is one, sensor which let's suppose there is one fire which heat reached the sensor and it melt that sensor, so the pressure will be released from the the piping system. So automatically the system will read that there is some fire, and the water will the water pump will start to pump the water.
No. Actually, what is the thing is we have two systems in this, like a pneumatic system and a electrical system. So the water is there up to the mark of the, we call it as that valve is called as deluge valve. That's it. It's not a deluge system in practical. So we have we have the system depend upon sensitivity, how your requirement is like. Okay. So here what is there? The air will be filled in this. So air need to be. So how this gets activated? There is a sensor. One sensor detection device is available which detects if there is a fire in the workplace. Or the second condition is there is a fuse bulb which is available. It should melt away. So if it only the fuse bulb is melting away, then the air is released and the water sprays on the work area. Then we call it as a single interlock system. Okay. So in double interlock system, both the detection device and this fuse should work together. So once both the things is works together, then the water gets released from the deluge valve. So there is a
single interlock is reaction, and the double interlock is deluge plus reaction combined.
Yeah, that's what deluge and pre-action combined.
Okay.
But usually we count in a pre-action only a single interlock and double interlock. This is what we are using in our workplace also. That's why I was saying this.
Okay, thank you, Mr. Mushtaq. Just carry on.
No. And the fourth one is like what are the various types of fire suppression systems, like what are the material present in that. So we usually use chemical clean agents, inert gases, and carbon dioxide system, that is called as FM 200, which we use in our workplace. And the other one is the water mist systems. And the other question is the difference between combustible and flammable liquids. So they have been classified on their flash points. So the flammable liquids have a flash point below 37.8 degrees or 100 degrees Fahrenheit. Usually in the book it's given 100 degrees Fahrenheit, because this 37.8 degrees centigrade I have given for my easy remembrance, just to understand the room temperature, how usually works in our place. So in our country, so that's easy for me to remember. So the next one is like a combustible liquids have a flash point at or above 100 degrees Fahrenheit and below 200 degrees Fahrenheit. So here there is a little bit there is a confusion in this, like the span is saying these readings, and the what we say David Yates has some other figures. So just for simple, I kept this one only. If we go for
No,
span,
I think in the David Yards they just give the classes of material, A1, A2, A3, and B. But there is no differentiation between the combustible liquid and
no.
this only
When we
says
when I speak to you, I referred the David Yates regarding this. So in that I see that so much details are given. But like in the David says, it's saying that the flammable liquids by class, like classes of flammable liquids by 1A, 1B, 1C, and the second one is 2A, 3A, 3A and 3B. So it was something related to that as far as I remember. The classification also was mentioned. I have mentioned here, yeah. I have written in the next classes also. So this is the difference between combustible and flammable liquids, and the fire point. So fire point is closely related to the flash point. So however, the fire point is defined as the temperature at which a substance will give off a sufficient vapor that will burn continuously after ignition. Usually the fire point is higher than the flash point. And the next one is what are the characteristics of combustible liquids by class. So here we have there is two things. One is combustible liquids, the seventh question, and the eighth question is related to the flammable liquids. So the combustible liquids have like 2, 3A and 3B. So in this liquid flash points, we usually in combustible we take the flash points only. And in this flash points, we have 100 degrees Fahrenheit and below 140 degrees Fahrenheit. And 3A, we have liquids having flash points above 140 degrees Fahrenheit and below 200 degrees Fahrenheit. So any liquids having flash point at or above 200 degrees Fahrenheit. So there was one question related to flammable liquids, I think, in the question number 11, which was talking about the characteristics of flammable liquids. So it is like at and above 100 degrees Fahrenheit, it was asking something like that. So here we can see that characteristics of flammable liquid by class 1A, like a flash point below 70 degrees Fahrenheit and a boiling point below 100 degrees Fahrenheit. And flash point, if 1B, we have a flash point below 73 degrees Fahrenheit and boiling point at or above 100 degrees Fahrenheit. And 1C, we have flash point at 73 and below, like a boiling point is below 100 degrees Fahrenheit. I forgot to write here boiling point here. So this is the first that domain. What is the domain?
Quiz one.
Quiz one question is over, and quiz 2 I was given only
Okay,
two
Mustafa,
things.
sorry, I want to ask something about these are the values you are taking from the span, the flash point below 73 degree F boiling point, or from David Yates.
I forget actually because I was confused between these two. I took I don't remember from where I have taken this point because
Okay.
2 days before I noted down this one, because I think somewhere here or the previous one the values I was a little bit confused, like the span is showing some value and this is showing a different value.
Yes. Okay.
But this is the easy one which I was able to remember, like 100 degrees and 140 below 140 and 140 and below 200, and the maximum 200 is for combustible liquids.
Yes.
So this question when we are practicing what is static electricity, we have come across during the quiz time, like it's a condition where a high voltage with low current occurs. So Saudi Arabia, we also have too much of static electricity. Yeah. And then the next is the examples of static generations are common with operations involving what kind of operations. So like whenever there is a movement of liquids like hydrocarbons or gases, contamination with particles or liquid particles and dust and fibers. So whenever there is a uh, any movement of liquids taking place, there is a chances of generating of static over there. So this may be asked just for information. I have written down this. So what are the protection methods to overcome the effects of static electricity? So I have written down in 3 steps. Like we need to identify the identification of potential static buildup areas. We need to identify. So the second one is the measures to reduce the rate of static electric generation. So what measures we need to take, and the third one is the provision of dissipator. Whatever the static electricity it has been generated, we need to have a provision to dissipate the accumulated static electrical charges. Okay, so the 12th question is like give the control measures to reduce the static electricity. So we have discussed last time during the session. I remember that we had talked about bonding and grounding. Okay, this is important, very much important. Inerting, so and humidity control. So I have not read about this. I have written down just like 5 o'clock, 5:30. I did not go into deep about the inerting and the humidity control. I thought of seeing what does it mean, because we are usually doing the bonding and grounding activity. So I thought of preparing for what does inerting means and humidity control. So if somebody can tell me about this, it will be helpful for everyone.
Humidity control, I will just, I am not about the inerting. For the humidity control, once there is a lot of humidity, the ground is wet. Let's suppose your cloth is wet. So at that condition, the water is, maybe there is some salt is also in the water. So this is a good conductor for electricity. So if there is a little small charges on your body, or on some other material, let's suppose a drum, high flammable drum, or some other things. Okay, so the charge is, the static electricity will just go towards the ground or some other things. So this is a humidity control. It is a good conductor for electricity.
Okay, because I
And
thought of
regarding the inerting mean, make it something, bring it to the zero potential. So I don't know how.
hello, hello.
So you can go ahead. You can.
Yeah. So because that's the reason of, like what is the effect of humidity on static electricity. So the lower the humidity, the higher the potential for static electricity build up. So if the humidity is less, then there is a higher potential that the static electricity built up will be more. So that's what I don't understand from Mr. Ashfaq's this thing, what he want to say. It is not clear, because that's what I thought of doing more research on this inerting, because we have the liquids, the flammable liquids, whichever we are transferring, we have a bonding and a grounding facility. How we do it in the workplace.
Mr. I think
Yeah.
when you are talking about the humidity, you are talking about conductive, because water is very conductive. When you are touching, when the water coming to the electrical like that, so it is sprayed for all of the phases, and they can do the spark and the fire can happen. So I think how to control this humidity. Number one, you have to use waterproofing devices like waterproof sockets, waterproof circuit breakers. And when you are doing your grounding system, you have to use some salted ground. You have to put some phosphate or something like that in the ground when you are making the ground. Like that, you are controlling the humidity.
Okay.
Thank you, Mohammed. Because I'm not sure, because I did not make research on that. I did not read much because the last.
Actually, what is the hazard with, for the water with the electrical? It is conductive, right?
Yeah, it's
Conductive.
conductive.
As we all know, it is conductive. So what is when we are working in construction site, if somebody using a plug or something like that, we always recommended waterproofing devices, right? For construction. That's what I think. What he will do more of that.
But my understanding regarding this is I did not understand how we will bring out the humidity if it is more or if it is less. How we will control that? I don't understand. That's the question.
I think you cannot control if it is the weather is humidity. So maybe you cannot export some material outside, or you have to put some more waterproofing devices like blood waterproofing, or you have to use all of the outage material. You have to put it inside or indoors like that. But you cannot control the weather. Impossible. Nobody will control the weather.
No, but the problem is the span has given that these are three are the control measures which we in order to reduce the static electricity. So maybe we need to think about it.
Number which question? Number what? 11?
It's 11th question, yeah.
Then which group, 1 or 2?
Group 2, group 2.
Group 2.
Shall I move to the next part or shall I wait for that?
Move to the next part. Just I will read it.
Yeah. The next one is like, what is the effect of flow rate and turbulence on static electricity? So whenever, because in the previous question number 10 also we discussed that the static electricity charges rate increases with the speed of separation. So whenever there is a force or some activity is going on, so when the flow rate is increasing, then the more number of static electricity will be generated, or because of turbulence also. And what kind of forces responsible for generating static electrical charges? Like the forces that is like flowing, mixing, pouring, pumping, filtering, or agitating materials when we are agitating in a mixer or something like that. So where there is a forceful separation of two like or unlike materials. So usually we do it like in maybe in the centrifugal machines also, I feel. So where we separate two like or unlike materials, so there is a chance that the static electricity is generated. So usually when I used to work in a pharmaceutical industry, we used to give the grounding for the equipment, because sometimes the centrifugal pumps or the machines you used to get fire. So because this is the reason why because of the static electricity being developed in that. So the 10th question in the unit 2 of the
excuse me, Mushtaq Shaikh.
yeah.
What is the meaning of speed of separation? What does it mean?
Like you know that when we are when we see in a centrifugal machine, you know, when inside small lab also we put a test tube and we run it with a force, okay, with the motor or something like that. When that is happening, what happens is we get two things separated, like the barium chloride, what I remember, like the barium chloride salt and the water solution, when I used to put into the centrifugal machine, so it used to separate into two layers. So in this it is talking about the charges, like usually it is talking about the charges like the positive and negative ions when this static electricity is usually happening by the agitation or the movement. So whenever there is a force applied to that, the two layers are getting separated. So here he is particularly talking about the like charges and unlike charges go together. In some in Spanish also some is telling like the positive electrons and the negative protons are getting separated with some force whenever there is a flow is happening. You got the answer or still?
Yeah, it is okay now.
Okay, and the last, the 10th question was like, it was asking among the particles like fume, mist, gas, and smoke, which is not a particle. It's asking. So just to explain, like fumes is like fumes we usually get from the welding. So where what we say like when we are doing welding activity, the solid particles get condensate from the gaseous state. So these are not gases or vapors. Okay, so these fumes are having some particles because it is going to the gaseous state and then it is condensating. So we have few particles in the fumes, and when we take mist also, it's a suspension of the water droplets or the droplet aerosols, what we call it as aerosols in the air. So generated by condensation of substance from the gases to the liquid state. So gas, because we talked about gas. Gas is a state of matter. We call it as a state of matter, which is at room temperature and pressure, atmospheric pressure. So which exists in its original state. That is a gas. So it doesn't have a particle. So similarly, the smoke also we have a suspension of carbon particles in air, or some burning substances. When we burn wood charcoal or some other thing, we get a smoke. So in this this was the question given to me for what is not a particle. So the answer is in this is the gas. So rest of the three has particles in them.
Okay, it's well explained. Well explained. So
Yeah.
so thank you, Mushtaq. Now, Muhammad Ishfaq, are you ready? Are you showing some graphs? Abdul
Imran
Latif.
Aslam. Yeah, Imran Aslam. This one is, I have sent you WhatsApp, okay? What Jawad Bhai told me that I have to send you that Excel sheet in WhatsApp. I have prepared by mistake that one, the question from 2017. The same fire protection, okay, but it is from span 2017 and domain 5 and question 2 and part number 8. So if you want me to explain that one, if you all guys, so I will go to that one to explain it. Otherwise, Ishfaq will explain it.
Okay. Now I am showing your question now.
Yeah.
So these are the questions.
Someone hear me?
This is from 2017.
Okay.
By mistake, I was thinking it is 2019, but today I came to know that it is 2017. So you want me to present this one, all guys, or Ishfaq will go through 2019, he will do it.
Ishfaq bhai, okay. Ishfaq bhai, have you are you prepared? Because Ishfaq bhai
Yeah, can
said
you
me
hear
that
me?
Ishfaq bhai said me that he will go to his room and open his laptop.
Yes.
Then he will show some
Yeah.
graphs.
Yeah, can you hear me now?
Yes. We
Yeah,
are.
Make me the presenter, please. I'll just
okay,
show
right.
something from the book, okay? So it will be clear to
Okay.
you people, maybe.
Okay. Now I'm doing this, but how can I do this? So just wait for stop sharing, or Safety Newton, can you make the Muhammad Ishfaq as a presenter? Yes, no, thank you very much. You can, Mohammed Ishfaq, you can now
Okay.
present. Thank.
I will just explain because my questions was regarding the fire alarm systems and how much types are there and what are the signals, etc., etc. Okay. So from this book, you can see that once we install a fire alarm system, there are three type of signals. One is called alarm signal, which is this one. The second is supervisory signals, and the third is trouble signals. Okay, what is the function of alarm signals? Alarm signals are giving us, it sends the signals to the central unit system that there is a fire. Okay, so it gives the alarm there. There is some maybe if this fire system is all the fire systems have this three type of signals. Once you are just install this, maybe you have in your office. So once there is any alarm, any fire, the alarm signal will do his duty and he will send the signal there. Other is supervisory signal. Supervisory signals are generally work to monitor the system that is there any trouble or not. There is one green bulb there in the central unit system. Okay, and some bulbs are there in the fire detection, and the sprinkles are the fire detector, smoke detector, etc. There is a green bulb, so this is supervisory signal are doing this type of duty that the system are okay. And if there is any trouble occur, the trouble signal will give the signal. Let's suppose if the sprinkle system is not working, your smoke detector is out of service, or there is any trouble in any zone in the system only. So the trouble signal will send the signal to the central unit system, and there will be a green bulb there, or there will be some different type of zone in the central unit system. So it will just it will give the red signal there. So that is the trouble signals. Now it's clear. How many type of signal? Three: alarm, supervisory, and trouble signal. Alarm will give it will work during the fire, any type of emergency. It will send the signal to the central unit system. Supervisory just supervising the systems, that system is functioning correctly or not. And the trouble signals, it will just if there is any trouble in the system, it will give the signal to the central unit system. Now it's clear to everyone.
Yes, MI, please tell us that is supervisory signal is doing doing the work. If there is a fault, then the supervisory signal will alarm.
No, supervisory signal is just supervising the system. Okay, if the system are okay or not. Once there is any trouble, let's suppose someone remove the smoke detector, or someone remove the sprinkle. Okay, so then the trouble signal will send the signal to the central unit system that someone removed the it will not say that someone removed, but it will see that the fire detector is missing. Which zone? It will also give you the zone detection.
Okay, now clear. Thank you.
Actually, what we have is we have a FACP, we call it as a fire alarm control panels. Okay, in fire alarm control panels, so whatever you're telling about the fault, so fault can be raised because of the maybe somebody, as Mr. Ishfaq has said, that maybe somebody has removed the smoke detector, or somebody has opened a valve. So we have a flow switch. So somebody has operated the.
Yes, the trouble signal will send the signal to the central unit system. Fire alarm central unit, FSCO. Now, hello, can you hear me?
Yes, you can proceed.
Mr. Ashfaq?
Yes.
Yeah, okay.
Okay, what is a protected premises? Protected premises are those premises which we are protecting against the fire. Okay, where we are installing the fire alarm system, maybe your warehouse, maybe your building, or maybe someone mic is can you mute mic? Whose mic is switched on?
Mushtaq,
Because my watch is coming again here, so I'm just getting
Abdul
confused.
Latif, you can also please mute your mic.
Yeah, so that is called the protected premises, where we install the fire alarm system. That is called the protected premises. Okay, now here, this is our protected premises. Now there are four type of fire alarm system. One is local, okay, one is remote, the other is proprietary, and the fourth one is it will come just a conventional system. What the local system will do, why we are installing the local system? This is only a simple system which is installed and a simple premises, and it just alert the people that there is a fire. Okay, there is a fire and the people will evacuate from the building. Clear? Now this is our building. Okay, here we have these fire detectors, here, everywhere. This C is the fire detector, this D is our alarm. Okay, and this is our central unit system. Okay, this is the manual switch, so it can be activated either by the fire detector, or it can be activated manually. If someone see the fire, so he will just push the button here at the B, okay, and it will activate the fire alarm system here at the D. So all the people will get alerted and all the people will evacuate from the building. This is called local alarm system. Now it's clear?
It's clear, easy. Okay.
Yeah, this is a simple system which is used only to alert the people. Conventional alarm system, this is the same as like this, the local fire alarm system, but here all the fire alarm system will activate at once. Okay, so this is called the conventional. Here only one fire alarm system will work because he will install here one. If we have two, so other section will not activate it. But here in the second system, conventional alarm system, all the fire alarm system will this here the detector, it will activate at once, and here the people will just come outside and they will see one by one that where is the problem. Okay, but this will not give you this zone, etc., etc. It will come downside and other system which is engineered more, and that is expensive. Zone conventional alarm system are installed in separate zone. Okay, it will also give here this in the control panel here, zone 1, zone 2, zone 3. If some now this is little bit more engineered as compared to the simple one. This is activating all, but here if let's suppose in zone 1 there is a problem, it will just detect only the zone 1. If there is a problem in zone 2, it will activate this system. So once the operator reach here, he will see that where is the problem, so he will just go directly there and he will solve that problem. Now okay.
Yeah, okay, clear.
Yeah, Decibel is more engineered now. It have more technology. It will initiating the alarm system display the location. It will also show the location to you that where let's suppose you have sprinkle one. This one is only zone wise. Okay, maybe in that zone there is 4 or 5 detectors, but here the addressable alarm system, they will just show you that which fire detector have the problem or where is the fire exactly. Maybe there is one room, room 2, room 3, there is one detector, A1, A2, A3. So if let's suppose in room 1 there is a fire, so it will also show you that let's suppose A1 detector is activated and the fire is in A1. That is called addressable alarm system. Okay. Now we will just come to the main section. This was all the remote, okay, local, conventional alarm system. Other is central, proprietary, and remote. These are the main three categories, and one is local, which is mentioned in the span. Central alarm system. In central alarm system, I will show you downside in this diagram. Okay, here this is the protected property 1, protected property number 2, protected property number 3. Here this insurance company installed here this his system for the fire alarm system, because nowadays there are some third parties which is monitoring your fire facilities, the protected fire facilities. They will charge from you and they will supervise your system, and they will provide their operator, everyone, you know, the trained persons who will be do the duty there for 24 hours. Okay, and he will monitor your you know, that is a competent person who know how to communicate during the fire emergency, etc., etc. So let's suppose in the oil refinery, etc., there are third party also working. So in this type of system, there are, let's suppose here one protected property, third protected property, and this is second and this is third. From all these property, the signal will come to the central telephone exchange. Here one operator will sit for 24, 1 or 2 or 3, depend upon the capacity of that system. Okay, once he will monitor this properties continuously for 24 hours. Okay, once he receive any signal from this property, because this is more expensive properties, so he will just immediately call the fire department. Okay, this is central unit telephone exchange, this is the central alarm console. Okay, here the operator will sit and he will just give directly the phone call to the fire department, and the fire department, the fire emergency department will reach to extinguish the fire. So this is happen generally in the central fire alarm system. In central fire alarm system, third party will give you the services, and he will also, the third party will do the maintenance and inspection also. This is the more important point, that because these two systems are same, proprietary and central, but in central, third party will give you the services for the maintenance and inspection, and you know, they will provide you the trained operators to monitor the whole system, and during any emergency he will call the fire department. Okay, and proprietary system are same like this one, but here in proprietary system the operator will be omitted, and the owner of that property, he will set his own operator, and you know, third party will not provide any services. They will just arrange, you know, this property owner, he will arrange the third party for the inspection of this all fire fighting system and for the maintenance, etc., etc. Here the third party is omitted from this. The property owner will set his own operator here, or trained person, for 24 hours, and he will give you the signal. Let's suppose if there is any emergency, he will communicate with the fire department. Now it's clear. Hello.
Yes,
Yeah,
yes,
it's
it was very clear.
Okay. In remote system, you know, there is no operator, not the owner are setting his own operator, or now there is third party. All the system is automatic, you know, and it's connected directly with the fire detection, you know, the fire department, the fire emergency department. Once there is any let's suppose a fire in this property or in this property, it will give the signal. Through which signal? The alarm signal. Okay, alarm signal will come here, then come here, and it will directly automatically goes to the fire department, you know. So this system is the best one, because it will reduce the timing, you know, for the contact timing, because if the maybe this person is outside, he will busy with his friend, etc., etc., and it will take time, you know, because in fire emergency time, 1 second is very important. So to reduce the timing, we are just using the remote system. In the remote system, all this signal will come here, and it will go directly automatically to the fire department system, and they will get alerted, and they will send the their emergency team. Remember, this property should always be outside from the protected property zone, because let's suppose if there fire happen and you put this property here in this area, maybe it will also get the fire, it will be affected from this fire, and it will not be able to give the signal to the fire department. So this property should always be outside from the protected property. Now it's clear? Okay, so there is how much systems? Local, central, proprietary, and remote. And local, it's only give the alarm to the local people, and they get alerted, they will come outside and they will see manually that where is the fire. And central system, this is the same system, but here the third party will give you the services, the operator, and he will contact the fire department emergency. And proprietary, there is no operator from the third party. The property owner will set his own person, and he will contact with the fire department, fire emergency department. And remote, this is all automatic. The signal will go directly to the municipality, because maybe there is some mention in the span that is automatically connected with the municipality. That will go directly to the fire department, fire emergency department, municipality, etc., who is giving this service for the fire extinguishing. Now it's clear. There are 4 systems.
Yeah,
Can anybody hear me?
yes, Ishfaq.
Is there any question?
Basically, the difference between the central and the remote. Basically, the main difference is that you already elaborated there. In a central, there is monitoring, but in remote, there is after when something happened, then teams will move for the extinguishing the fire or for the emergency.
Yes, you know, in the central, I told you that all the signal are coming here, and here is one operator, you know, who see from the screen, or there is any device from which he see that there is a fire. Then he will take the phone and he will call the fire department that here is the fire, and property number 3 or property number 2, etc. He will give the address, this other subject, but he will call the fire department by himself manually. In remote system, all things are, you know, programmed automatically, and it is programmed directly to contact with the fire department. You know, you can say that the signal is not coming here, it's coming directly here to this fire detection system, fire department. Okay, so it will just you know, reduce the time of emergency.
Then we can say that the remote system is so we can say that the remote system is very quick, efficient, or in a timely manner we can extinguish the fire, or we can reach the emergency location.
Yes, that is good. This is very, you know, quick system, but this is very expensive.
Okay.
Now it's clear?
Yes, now clear.
Okay, so my one question was regarding this, you know, these 4 systems: central, proprietary, remote, and the local. Okay, so I think no need to go to the span. I already explained the thing to you, so we'll just move to the another questions.
Ashfaq, one question for me. What if some false alarm goes to the remote area? So how they will handle it? Then it will be a nuisance, right? So how we are going to control in this those kind of things?
This is not mentioned here in the book, but maybe there will be some, you know, during the inspection there is some monthly inspections and maybe a quarterly inspection. They are checking all the things. So there will be definitely some program for that it will not take the false alarm there. But no problem, if there is any false alarm there, the fire department should provide the service, because they cannot believe that this is the real are false. Because if they believe that maybe this is the false and there all the property is burned, because they are taking money for this, so they should provide the service.
Okay, okay. Because we are having both the things, like the local and the proprietary alarm systems are available with us. We don't have the remote one. So we face we face continuously this false alarm issue. It is very because we are not able to address it properly. So how we need to address, I don't know actually.
Actually, I did not read about that because of the lack of time, and maybe there will be some solution for that. Because if so there will definitely some solution.
Actually, I'm talking about the practical issue which we are facing.
Yeah. So I did not read about that, how to encounter that problem, but I just read about the system only.
It was very nice. I understand the difference, because in local I was thinking, because only two systems, like the conventional system and addressable systems. I was not knowing that in local we have again a local alarm system. That was very well explained by you, and the conventional alarm system and the addressable alarm system. So again, in the conventional alarm system, you have explained about the zone conventional alarm system. That was very nice. So in this local, we have the fourth one also. Only three we are having: the local alarm system, conventional alarm system, addressable alarm system.
Addressable alarm system. There are three, but this is upon its technology. Local is very simple, and conventional, that will give you the zone-wise signal. That maybe zone 1 or floor 1, floor 2 have some problem. And addressable, it will give the exact location of the detector there. Here is the problem.
Yeah. Because we are having one more thing also. We have a VESDA system also here, like a very early smoke detecting apparatus. So that is also connected to this addressable system. So it tells you the exact location, from which location this is coming out. Very nice, very nice. Very helpful, very helpful. Thank you.
You're welcome. This was all about this one question. My second question was about the blue. BL, because I cannot now go to the span, it will take time. BLEVE. Okay. If you want, I will just go to the span, no problem, to open the span. Just give me 2 minutes, okay? Okay, no, forget about this. Let's go directly to the explanation. Blue is actually the boiling liquid vapor explosion. Okay.
Expanding vapor explosion.
Yeah, expansion.
Expansion. Yes.
Expanding.
Yeah. Okay.
Expanding.
Expanding vapor explosion.
Yes. How it's happened? If you want to, I will just show you one video small for 1 minute. That will be very good for you people. Maybe the one who don't know about that, he will know about this very clearly, because this is very important. For the exam, I faced this one time. This one is very small video. You just see this. Now here, sometime we see that there is a fire in the oil refineries. Maybe you watch that on the YouTube or the news, and very big explosion occur. Very big explosion. Okay, a very big fire. There is a fire, and after some time there is a very big explosion. Why it happening? That is called blue. That is due to the blue phenomena. What is happening actually here? This is a pressurized vessel, not pressurized but enclosed vessel. Okay, It is completely enclosed because here is evaporative material just like petrol or naphtha or some other things. Now here is the fire outside. This fire is coming in contact with the shell of this vessel and it give heat to the inside liquid. So this is the liquid level now. After some time, this liquid will evaporate, become vapors, and this pressure vessel will pressurize inside. All this vapor will go. This liquid will goes to the vapor state, and it will get pressurized. Same like Charles' law. Charles' law states that the pressure is directly proportional to the temperature under the constant pressure, the constant volume. Sorry, if the volume is constant and you are giving temperature to some vessel and there is any liquid or something inside, so the volume, the pressure inside of that vessel increase. Why? Because here the molecule are getting energy, so it will escape from the surface of this liquid and it will go to the vapor state. Now this vapor, this pressure is inside of this vessel increase. Already the place point reached. So once it reach to the set point of this vessels, it will, the vessel will explode and it will give a big fire. Now see, just go for 1 minute. You can watch this video. It will be very clear to you. Now it's clear to all of you.
Yes, yes, nice, very nice.
Yeah, thank you. And now you can move. I think my section is over. So another person can present his part.
Okay, Muhammad Asghar, Assalamu alaikum. Are you sharing something? Your assigned questions?
Imran bhai, I shared on Thursday and I did my part on Thursday. Today there was nothing assigned to me.
Okay,
Okay,
your assigned question is completed, I think.
Yeah, completely, yes.
Okay. I have 16 questions, but in practice. There's no, it's just no more explanations. It's just I put like MCQs.
Oh. Okay, Muhammad, if you have some questions, then you can share.
Okay. How can I open this one?
Safety Newton, if you can hear us, just make presenter Mr. Muhammad Munsif.
So first questions, we asked which chemical group have more potential incompatibility rather than any groups with other chemicals. which it cannot be reacted. If you wanted to make more explanations, it is not good for reactions rather than any other group in chemicals. Hydrocarbons, solvents, strong oxidizers, amino acids. Sorry, this amino acid. So A, B, C, D, which answers?
Is a B solvents?
No. Strong oxidizers. Okay. And the strong oxidizers, most of the reactions of this one only to provide oxygens. It is not actually reacted easily with anything, only until it comes into water to be more suitable. For this oxidizers, always starting, when you're naming this oxidizer, always starting by bare. Like, for example, bare oxide. Like, for example, bare chloride. Okay? And most of the names also ended by A, A-T-E. Okay? Like, for example, methyl chlorates, like iodates. For these reasons, okay, this oxidizer always dismantle one oxygen or two oxygens, but it is not reacted with anything. Reaction come from the oxygen, always releasing from these oxidizers to another reaction. How it can react it? Sometime I have to using a waters or solvents like waters to make it more reactive. Okay, so the answer is C. It's clear?
Yes, it's clear.
Yes.
Okay. Until carefully controlled condition, oxidizer should not stored with any other material, water, flammable, or metal. Which type? Which I cannot storage this oxidizer with which type of these materials? Okay.
It's a flammable. C, flammable.
No, actually, we know it should not be storage with flammable, but most of recommendation it should not storage with any other material. It should be isolated. Okay, because why? Because any other material in some phases it is not flammable, but with some reaction with another material it can be flammable. That's why I cannot storage this oxidizer with any other material. Okay, so the answer is A.
Okay.
Okay, which of the following is not an oxidizer? Okay, bare chloric acids, metallic iodates, hydrogen peroxide, or heliums. Which from these four are not oxidizers?
I think it's helium.
Yes. Okay, like this question, if it come, actually he testing us how to name the oxidizers. Oxidizer in most of the oxidizer is starting the word by bare, like bare chlorides, okay? And most of the oxidizer ended by A-T-E, like iodates, okay? So here, bare chloride acids, okay? Actually, starting with bare. And here, metallic iodates ended by ATE, okay? And here, hydrogen peroxide, also peroxide, BER. But helium, actually, it is not oxidizers, okay? But it is not matching with, it is only different from the naming, but all of these three are matching from the principle of the naming of the oxidizers, okay? But that is not all. Sometimes chlorine is oxidizer, chlorine is oxidizers, okay? Ferric salt also is oxidizer. Iodine is oxidizer. Okay, but if this question comes, he should know or testing us how to name these oxidizers. Okay. A storage for the questions. Storage using inside the room must be normally compliant with which NFPA. NFPA 30, NFPA 35, 350, NFPA 101, NFPA 70. So the
Is it NFPA 30?
NFPA
30. 30.
Yes. Yes, yes, yes. Okay. 30 of the storage. Okay, of the storage. 350 for confined space. 101 for life and safety. 70 for
life and
electrical.
safety.
Okay.
Exactly.
So arrived at 4-inch seal to the pavement, remove any spillage material, self-closing fire door, and some type of exhaust system is the requirement of which NFPA. Okay, the same question also, because we are talking about the principle of the storage. NFPA 350, NFPA 101, NFPA 30, or NFPA 70.
I think it is NFPA 70.
No, actually we are talking also still about the storage procedure. The same thing also.
NFPA 30.
Yes, yes. Okay, about the procedure of the sealing. Okay, and closing the fire door. All of this requirement and the exhaust system. All of this requirement of the storage. Okay, storage area which I will be storage some material sometimes flammable or contain some flammables. Okay, flammable inside the storage location must be provided with one clear acyl at least 3-inch, 3 feet, 22-inch, 26-inch. Sorry, here access. Yes, access. Clear
Location
access.
must.
Nobody has answered?
3 feet?
Yes. Okay, 3 feet. Okay, not 3-inch, not 22-inch, but 3 feet. Okay. The minimum weight of the exist axis in most of the business in construction 3-inch, 3 feet, 22-inch, 36-inch.
Minimum. Is it 36 inches?
Yes, yes, yes. Actually, there is only exception for the constructions. Okay, it will be 36-inch. Here, I think we move to the questions. Okay, charted by supersonic flammable budgets and velocity perhaps up to 2,000 meter per second, and substatics over pressures up to 20 bars. What is this? Okay, propagations detentions, detonations, deflagrations, auto engines.
It's C, deflagrations.
I said
C.
no.
C.
Deflagrations.
Yes, for question number 9, the answer is C, deflagration.
Actually, the answer is B. Deflagrations actually is subsonics because actually it is transfers the heat from the area to another area. Okay, and there is no need for more speed. But detonations, it is explosive, high explosive, need more pressures and need actually also more speed. So it is around supersonic, not subsonics. So detonations is always related to explosive. But deflagrations, most of them are, all of them are explosive. But this one, which you see bombing or something like that. But deflagration only transferring the fire. So sometimes this explosive can include both of them. When the fire transfer from the detonation phase into deflagration phase. How? Because it will be complete the triangle of the fire. So in this case, so the explosive will include fire. Like any military bomb or something like that. So here the answer is B. Okay? A rapid high energy, okay, release compensation event that propagates through a gases or another explosive material at subsonic speed, driven by transfer the heat. Again, propagations, detonations, deflagrations, auto engines. Make sure the answer keyword is subsonic.
This is deflagration.
Deflagration, yes.
Because if it's subsonic, then subsonic is deflagration.
Yes, it is transfer the heat. Okay, just to transfer the heat from the cold area or from the hot area to the cold area. Okay. Sorry.
No, Mr. Muhammad.
Yes.
You know, deflagration. This is not the transfer the area from heat from cold to hot area. This is some type of combustion. You know, there are two things. One is detonation, or other is deflagration.
Yes.
Detonation, the deflagration. Let's suppose I show you the blue example. You know, once the fuel, burn, and that flame is called deflagration. This flame explosion is deflagration.
Yes.
And there is and it travel with the speed of less than sound. Subsonic mean the speed less than sound. The sound speed is 330 meter per second. So it will be either 300, 200, depend upon the type of explosion.
Yes. So as you see, the difference between
now
them.
you can move.
Between them, as you say, it is about transferring the heat, and sometimes it is transferring the fire. So both of them, if they are combined, so it will be fire explosive. Okay. If both of them are combined, it will be a fire explosive.
Yes. Sometimes, let's suppose if we fill the balloon with the gas, sometimes we are flying the balloons. So if you fill that with this, let's suppose methane gas or something other gas, And you once we were kid, we were playing this type of game. We will fill the balloon with the gas and we will put some fire downside there and we will fly it. Once it reach the air upside, it will explode there. That explosion, it was actually deflagration. You know, the sudden combustion of gas is called deflagration. Let's suppose if you fill the room, you know, nowadays we are putting some gas heater inside the room, and if the gas are leaking, no one noticed that, and someone just give the fire, let's suppose heat source, fire source, so all the room will get fire immediately. That is called deflagration.
Yeah, but important for your point now, as you discuss, also we have to remember something. When the fire comes from explosive, okay, very strong explosive, so which starts? Detonations or deflagrations?
If it's from the fire, it's deflagration. But sometimes, you know, the structure of the property and, you know, the confinement, that is also lead to the.
He said detonation at first, then it comes deflagrations. So it is explosive already. And after that, if I complete all of the requirement of fire, so it will be deflagrations coming, because it will transfer the heat or the fire from area to another area. So it will be combination between them. Okay.
The deflagration are just due to the detonation. It depends on the structure and, you know, the confinement of that gases. You know, suppose if the gas is confined in a small vessel, it will explode the vessel. So it will just, you know, lead to the detonation.
So as we said before, the explosive, the first explosive, which is need some spray or some spray of the material. So this one is detonations. But after that, when it transfer into fire phases, okay, and you see the fire everywhere, so it becomes deflagrations.
Yes, but the detonation will occur first. Same like I show in the blue example, you know, it explode the vessel. Yeah, that explode, you know, the particle of that vessel that was moving with the supersonic speed. Same like missile. That was detonation. But after that, there was a big fire. That is deflagration.
Yes. Okay.
Thank you. Let's continue.
Okay, we'll continue. Here also the another examples as another questions. Sorry, because deflagration to detonations transfer refers to the phenomena in the engine mixtures of the flammable gases, air and oxygen when sudden transition take place from, look here, deflagration type of compensation to detonation. There is another example also here, okay, because sometimes when you are fire something, it can be also bombing or transferring into detonations type. In this type, in this most beginning form of a deflagration may be simply of which type? Flash fire, flash point, boiling point, strong oxidizers. This agent which effect transferring of deflagration into detonations. At which time?
So we did not go to the question.
Something, as you say, I am heating something. This heat until to some temperature, it will be explosive. But now it's fire. But it will be explosive until it comes to some level of this fire. So this level, what we are calling flash fire, flash point, boiling point, strong oxidizers.
Should be, I think, strong oxidizer, because if it's moving from flammable gases and it give detonation, so I think it should be oxidizer to give explosion.
Yes, remember I am talking about phenomena. I am talking about phenomena. I'm not talking about something.
Yeah.
So
then
we are calling this case by that.
confused
So
about your
first of
question.
all, we have to ignore this strong oxidizer. We have to look in between these three only. So A, B, C.
Detonation, transition, reflective phenomena in the share of the when the
Actually,
student
it is calling a flash fire. Okay, this phonema calling a flash fire. This flash fire which transfer deflagration into detonation. Just I am heating until explosive or until the pressure and the supersonic come. Okay.
So this phenomenon is called flash fire.
Flash fire. Yes.
Okay.
With the light component, the flash point of temperature required is higher than the flash point temperature required for heavy components, or
light
is equal to the flash point of the required of heavy component, or less than the flash point temperature required for the heavy component. Which one of these three? Now you know that sometime when I heated something, it comes to the flash point, or yes, flash point. It will mean it will gain some fire. So I have two types of component: heavy component and light component.
This is answer C.
Which need less fire, less temperature to reach to the flash point.
The lighter component will require less temperature. So this is answer C. So the flash point will be less.
But actually the answer will be A. Why?
Oh.
Actually, in the DVDX, if you see the difference between the light component and the heavy component, okay, the difference between them, light component have exposed more vibro. So with more vibro, you need the lowest or latest flash point temperature. But for heavy components, the vibro, okay, the rating of the vibro is very slow or less than the light component. So in this case, you need more than temperature to reach to the flash point. So the flash point depending
Mr. Muhammad. Mr. Muhammad.
Yes.
You know, we have a lighter component, naphtha, petrol, and the higher change chemical compound, you know, hydrocarbons are, you know, you can go to the last one, star, or, you know, bitumen. So the flash point of petrol, I think, is minus 15 degrees centigrade. And if you are going toward the bitumen or some tar, it's more than 200 or 300 degrees centigrade. So the lighter components always have less flash point.
The difference between benzene, okay, or gasoline and diesel. Okay, all of us know this. Okay, maybe if you bought get 2 cup from the gasoline and the other one is diesel, and you leave them in the fresh air, you will see that the cup of diesel already decrease more than the diesel. The cup of gasoline decrease more than the diesel. What is the reason of this decrease? The vibro rate. Increase the vibro, okay, outside. So with this vibro, okay, I will increase the pressures. With the pressure, the flash point is only need less than flash point to get the fire. Like when you are firing, so in this case, as you know, when we are firing, gasoline is higher than in the rate of the fire, or need more less than temperature than the diesel. Most of the vehicle of diesel need you leave the car maybe around 5 minutes until you move it. But for gasoline vehicles, you can move quickly. Why? Because they need only simple temperature to reach to the flash point, to start to fire the gasoline. But for diesel, you need more temperatures, around maybe 60 cellulose. Okay, why? That is why, because the vibro rate of diesel is less than the vibro rate of gasoline. That's why we can say the gasoline is light or lighter than the diesel. Okay?
Okay.
Okay, about ICS. Here, because I like when I give discussions about this, I need everything to be available. Okay. ICS, I think it is incident, command, okay, comments. They are calling like that, incident comment, okay, or incident comment section, ICS. So it is have three components or have some component. What is not from this choice is not component of ICS. Incident comment stuff, okay, general stuff, positions, a single incident commanders. Which one?
What?
Is not part or not a component or not a main component of ICS. Incident comments, common stuff, general stuff, positions, single incident commander.
This is a incident command. The other three are the components.
No, actually here the ICS are
Incident
three
command
main
system.
components: incident command, common stuff, and general stuff position. But here in the general stuff position, sometimes have, okay, or have subdivision, have single incident commanders or a unified command. Okay, so the answer will be D. Okay.
Okay.
So
Thank
here
you
we
for
come to
correction.
the responsibility of the positions. Okay, so for ICS or incident comment, or sorry, for comment stuff, we have three positions. Okay, we have three positions. We will talk of them in the coming questions. Who is responsible for the same operations of all tasks performed on the site from the CS positions? A safety officer, a public information officer, emissions officers, emergency supervisor.
Oh, we did not get this,
Emergency
Muhammad.
supervisor.
I think it's emergency supervisor.
Actually, emergency
supervisor.
supervisor, no, safety officer. Safety officer is responsible for the safety, and he have all of the authority to stop any task not safe. Okay, and he have to interfere in any procedure he found is not performing, and he also can interfere in any another positions or stop any another position is not performing his position in safe manners. So it is the safety officer. Okay, who is responsible for passing information regarding the incident to the public and the media, from the CS positions? Safety officer, public information officer, liaison officers, emergency supervisor.
Liaison officer.
Public.
What?
Liaison
Public
officer.
information officer. B.
Yes, it is B. Okay, public information officers, he is the one who have to transfer all of the information, and this man, he should be updated with all of the latest requirement to using the social media or the automations work, and he should know how to using this. Okay, So the one who's responsible for interact and coordination, okay, not only transferation but coordination, other response of intents not responsible, represented in the incident to provide their input on the legal issue and the resource available from the CS positions. So this position, he is the one who can make coordinate with other requirements like legal authority, emergency response, safety officer. He is the point of communications. Who is this from that? Safety officer, public information officer, emergency supervisors, liaisons officer.
See, liaisons officer.
Yes, liaisons officers. So from this, we have for command staff only 3 positions. Safety officers, responsible for the safety of the people. Public information officer, he is the one who's responsible for transferring the information in social media and just reporting like that. And liaisons officers is the communication center. Okay, the emergency supervisor is not included in this part. Okay, there is my 15 questions. Okay.
Okay, very nice, Mohammed.
Thank you.
Now it's time to, I think, all the today is the very good session, and all the participants share something and increase the knowledge. I think if there is nothing more, so we can hang off, or if there is any input.
Just everybody can make his file in PDF and transfer it. It will be good. What he said today, like what I said, I will transfer it to all. Okay, in our private group, because we need to study or review all of that again.
Yes, right. Imran Aslam, what is the plan for tomorrow?
I think some of the fellows like Abdul Ghaffar, Numan, Adil has assigned question remaining from the span. So tomorrow I will, in the morning, I will keep in touch with them, and if they are agree to share on the, then we will other contingency plan for tomorrow's work, because we have no any other domain assigned, any other domain assigned. So, and another thing is that if we other thing, my suggestion is that if I assign tomorrow a new domain, so then we decide the name of the next domain, so that tomorrow we will discuss the remaining question of fire and domain 4, and the next domain which we decided now. So your inputs are required.
Okay, what is the next? Environmental science, environmental safety.
Yes, it's good, but Muhammad, are you agree on environmental section? Or
Environmental, I think, is the best one who can explain in Mr. Jawid, because he already master degree and he is now preparing for PhD degree in environmental, and he promised he will do it. So we need someone because as you know, most of us, yes, we are calling ourselves HSC, but I am sure most of us not looking too much to the environment. So we need somebody already, when we read it, he have more experience. Okay, so I think Mr. Jawidi is the best one, or I don't know, maybe, or I know that he have already master degree and he's doing now his PhD degree in environmental.
Actually, recently we did the chapter from years about ergonomics. So I think we will touch the ergonomics domain.
Yes, actually, yes, we can go for ergonomic domain. Yes, we need to go for ergonomic domain because it is really chapter.
Okay. So
It is a
Mushtaq
very
Shaikh and Muhammad Ishfaq and Muhammad Asghar, please give your inputs.
Yeah, okay, no problem. Any
No
domain.
problem. Anything, any domain which is related to our study is good for us.
Yeah, we have to
Okay.
cover all the domains. So whether it is environmental or ergonomics or whatever, so no problem.
What I feel is still in fire. We are having more questions left. I think we need to cover all those things.
Yes. So tomorrow we will have a section on our remaining question of domain 4, fire and safety, and then I will prepare a scheme for the ergonomics as well. So and circulate to the group, and then we will discuss on a scheme, and then after the finishing the domain 4, then we will start the ergonomics domain. I think this is the
What you can right now, you can share the ergonomic scheme. It'll take time for me because I don't have proper system to prepare, and the internet and all this are having some difficulties here. So it's better because it'll take 2 days at least, so that by day after tomorrow we are ready with that.
okay.
Imran bhai, I think it is better to share a question which we have to prepare tonight.
Yes, after what I will do now, I will send it now what I did to all of you.
Okay, I'm basically it's 11 at Pakistan time, so I'm trying to, but in the early morning I will send to you the ergonomics related assigned question from a span. So and also I'm also circulating the remaining questions from the domain 4, fire and safety.
Okay, no problem.
Okay. Thank you.
Okay, now time to hang off. Thank you. Allah Hafiz. Allah Hafiz.
Okay, I will send now and I will go.
Okay.